Hello everyone, I'm Shivani and welcome to Civil Series. First question is from Building Material and Construction. So question is, in the context of timber, which kind of defect is shown in given figure? This is given figure and these are the options. In the given figure, one thing is observing that cracks are formed from outer side to inner side of this timber. Okay, let's first discuss the parts of timber. The central part of this timber is pith, and after pith there is heartwood, then after heartwood there is sapwood, then after sapwood there is cambium layer, after cambium layer there is inner bark, and after inner bark there is outer bark, which is the outermost layer of timber. Okay, and these all layers are considered as a annular rings, and there are medullary rings which are perpendicular to the all annular rings. Okay, so here in this figure, one thing is observing that the cracks at the outermost part are broader than the innermost part. So the cracks are forming from outer part, means from bark towards the sapwood. Therefore, these types of defects are called as star shakes. So these are the star shakes. Star shakes are the cracks propagating from near the edge of the log towards the center. Okay, so in this question, only discussing the answer is not enough. Okay, so for overall study or complete conceptual clearance, you need to see other options from the question. So first we see the heart shake, knots and cup shake before moving to the second question. Here, these are the figures related to the defects in a timber. First is a cup shake, which is partial split up of timber due to the shrinkage of timber or uneven growth of timber. Similarly, ring shakes. Ring shake is a complete split up of timber due to uneven growth or due to shrinkage of timber. Okay, then next is heart shakes. Heart shakes are opposite to the star shake. In case of star shakes, the cracks are formed from outer part to inner part, but in case of heart shakes, the cracks are formed from inner side to outer side. Then next is knot. Knot is a defect formed in a timber due to cut off or die off of branch from the timber or a tree. Then this is the theoretical part related to heart shake, knot and cup shake. You can go through this. Then second question is from strength of material. Question is, the deflection at the center of simply supported beam length L. Okay, beam length is L, carrying a point load W at the center. Okay, here the simply supported beam is given and the length is L with a point load W at its center. Here the condition is given and they ask deflection related to this condition. Okay, these are the options given. Here this is the simply supported beam. Then the length is L with point load W at its center. Okay, to find out the deflection of any beam, first we know the bending moment and slope related to that beam. Then the maximum bending moment for this simply supported beam with length L and point load W at its center is WL by 4. If you haven't any clue related to maximum bending moment or shear force, then you can check a mechanics playlist from my channel, or else I will put the link in description or in comment section. Then next, with the help of maximum bending moment, you can find the slope. Okay, the slope is ml by 4 ei. Okay, these are the different formulas for the slope and deflection. I will provide you a chart of different conditions of beams and loadings. For that different conditions of beam and loading, there are different slope and deflections. You can go through that chart for all the different conditions. So for this beam, the slope is ml by 4 ei. Okay, here just replace the m with maximum bending moment, so the slope is WL square divided by 16 EI. Then next is deflection. Deflection is slope into L by 3. Therefore, the deflection for this beam is WL cube divided by 48 EI. Option number first is the correct answer. Then next, this is the chart for the different conditions of beam with different loadings. First is the cantilever beam with movement at its end. Then second is cantilever beam with point load at its end. Third is the cantilever beam with UDL. Fourth is a cantilever beam with uniformly distributed load. Third is the simply supported beam with point load. Fourth is the simply supported beam with uniformly distributed load. These are the maximum bending moment for this different kind of beams. These are the slope and these are the deflections. Then next third question is from the building material and construction. Question is, which of the following is not the property of plaster of Paris? Okay, plaster of Paris is the building material. So here three properties are given, and in that three properties they ask us that which is not the property of plaster of Paris. So first, specific gravity is 1.2, not correct. Specific gravity of plaster of Paris is 2.57. Okay, I repeat again, specific gravity of plaster of Paris is 2.57. Then next point, black in color. No, plaster of Paris is white in color. Okay, so first is wrong, second is wrong. Then third, setting time is 5 to 10 minutes. Yes, this is correct. Then from the option, first and second is wrong. So here they ask not the property. So the option is only 1 and 2. So these are some extra points related to plaster of Paris properties. So plaster of Paris is non-inflammable, non-combustible. It has a very low chemical reactivity, and in extreme condition it acts as an oxidizing agent. Plaster of Paris has a high fire resistance, and this material is ideal to heat insulation. The next fourth question is from the centrifugal pump. Question is, in the context of centrifugal pump efficiency, which of the following is a correct equation of manometric efficiency? Okay, so here they just asked the formula of manometric efficiency. So from the options, first, weight of water lifted divided by 1000. No, this is not the formula. Then second, manometric head into head imparted by impeller to water. No, if this multiplication is replaced with division, then this option is correct. Okay, but because of this multiplication, this option is wrong. Then next, power at the impeller to power at the shaft. No, this is not a manometric efficiency. This is the mechanical efficiency. Power at the shaft, power at the impeller to power at the shaft is the mechanical efficiency. Then next, manometric head to head imparted by impeller to water. Yes, this is the correct option. The manometric efficiency is manometric head to head imparted by impeller to water. Then this is the formula for mechanical efficiency, which is power at the impeller to power at the shaft. Then overall efficiency is the product of manometric efficiency and mechanical efficiency. Then next, fifth question is from estimation, costing and valuation. This is question related to the unit of measurement. Okay, here the question is given. Here on the left side the items are given, and on the right side the unit of measurements are given. First is railing, second is centering and shuttering, third is gusset plate. Okay, so railing is measured in meter, centering and shuttering. Centering and shuttering are the formwork related parts or formwork related terms which are measured in square meter or meter square. And then gusset plate, which are used to joint or which are used to form a joint. Okay, and these are measured in quintal. So these are the correct options for the unit of measurement. Railing is measured in meter, centering and shuttering is measured in square meter, gusset plate is measured in quintal. Then these are the some particular atoms and with their unit of measurement. You can go through this table and this is very useful. Then next, sixth question is from pre-stressed concrete. Okay, question number 6. Dash is a method of pre-stressing in which tendons are placed inside ducts or passages provided in concrete after concrete gain a sufficient strength. Okay, so here focus on this after. Okay, here pre-stressing in which tendons are placed inside the ducts or passages. Tendons are placed inside the duct or passages provided in concrete after concrete gains sufficient strength. Okay, after means post. Okay, so here the answer should be post tensioning. Okay, so from this option, the option number first is correct here. Then pre-tensioning means before. Okay, steel wires are tensioned before concrete is placed and hardened. Then anchorage is also called as fastening, and these fastenings or anchorage are used to connect the structural and non-structural components to a concrete structure. Then full pre-stressing that this is the level of pressing in which no tensile stress is allowed in a concrete under service load. Okay, then next question is from construction planning and management. Question number 7. Question is, in the context of measuring of safety injury index. Okay, in the context of measuring of safety injury index expressed by which of the following equation? Here the question is same. Here they just ask the formula of injury index. Okay, so in the first three options the numerator is same but the denominator is changed. So for injury index the denominator is always 1000 and the numerator is injury frequency rate into injury into severity rate. Okay, so this is the formula for injury index. The correct answer is option number 2. Then next question is from irrigation engineering. Question number 8. Which of the following statement is correct regarding lining of irrigation channels? Okay, so here they ask a correct option regarding the irrigation channel. So first is lining of canal prevent and reduces the weed growth. Yes, it prevent and reduce the weed growth. Also, it prevent the seepage and reduces the seepage loss. Okay, then first option is correct. Then second, earth type lining is a type of canal lining. Yes, and also a hard surface lining. Okay, earth type lining or second is hard surface lining. These two are the types of canal lining. So both options are correct. So answer is both first and second. Option number 3 is correct. Then canal lining. Canal lining is some kind of lining which is used to waterlog or to prevent the seepage of water or to prevent the percolation of water from ground reservoir. Okay. Then next question is from irrigation engineering. Question number 9. Question is, dash consists of undressed stone block set in mortar and laid over a prepared subgrade. Okay, so these are the options and the answer is stone block lining. Okay, so stone block lining is laid with the cement mortar or lime mortar for the canal lining. And that stone block lining is also the undressed stone block set in a mortar and which is laid over a prepared subgrade. So the correct answer is stone block lining. Then we'll see the other options. So clay puddle lining, which is a traditional material for a lining of canals, and which is other waterways, which is used for the other waterways and as well as for repairing the leaks in earthen dams. Then soil cement lining. That soil cement lining, it consists of a cement which is very minimum, which is 2 to 8% by the volume of soil. Okay, in the soil cement lining, two ingredients are there, only soil and cement. Soil is in very large quantity, and by 2 to 8% of soil quantity, there is cement. Okay, within a definite proportion, and this is used to line the canal. Then next is asphaltic lining. Asphaltic lining is the combination of cement and sand with hot condition, and this is also used to line the canals and the irrigation system. 11th question is, which of the following is a desirable property of soil as a highway material? Okay, so here they ask the property of soil as a highway material. So first is compressibility. No, compressibility is not the property of soil. Second, stability. Yes, for the highway material, stability of material or stability of soil is required. Then permanency of strength. Yes, strength is also required. So the option number second and third is correct for this question. Yeah, then these are the some extra properties for the soil, which is ease of compaction and good drainage. Then question number 12. In the context of straight line method of calculating depreciation, which of the following is correct expression for annual depreciation? Okay, so here they just ask the formula related to annual depreciation. So D in the formula is annual depreciation, C is the original cost, S is the scrap value, and N is the life in year. So this is going to be the answer, which is option number first. D is equal to C minus S divided by N. Means annual depreciation is equals to original cost minus scrap value divided by life in year. Then question number 13. Which of the following is organizational approach to improve safety in construction? Okay, so the options are safety in department, committee, and safety cost. So all of three are correct. So the option number 4 is the correct answer here. So these are the some organizational approach. So you can go through that. Then question number 14. Which of the following is correct equation of relative compaction? So here, where RC is relative compaction, then gamma D is a dry density of soil, then gamma D max is a maximum dry density from compaction test. Okay, here also they ask a formula related to relative compaction. So the relative compaction is gamma D by gamma D max. Means the ratio of dry density of soil to the maximum dry density from compaction test is the relative compaction. Question number 15. Pre-stressed concrete is classified into which of the following? So this is very simple question. So pre-stressed concrete is classified into pre-tension and post-tension concrete both. Okay, the option number third is correct. Then question number 16. Which of the following factors are affecting the shear strength or shear resistance of a RC member? Okay, so here they ask a factor which affect the shear resistance of reinforced concrete member. So the options are grade of concrete, ratio of shear span to effective span, and then compressive force. Okay, so grade of concrete is a very important factor and which affect the shear resistance. Then second is the ratio of shear span to effective span. This also affects the shear resistance. And then compressive force, because RC or the reinforced concrete, here the concrete is weak or strong in compression. So compressive force is also considered here. So all the three options are correct. and also the size of aggregate and depth of member affect the shear resistance of RC member. Question number 17. In context of signals for ranging in survey, match the following signals by the surveyor to action by the assistant. Okay, so for ranging, these are the signals and actions. So first, for a slow sweep with right hand. So for a slow sweep with right hand, the option is move slowly to the right. Okay, here they ask for a right hand, slow sweep with right hand. So the answer is move slowly to the right. If they ask for left hand, so slow sweep with left hand, then answer should be move slowly to the left. Okay. Then second, right arm extended. Right arm extended. The answer is continue to move to the right. Okay. Like that, if they ask for left arm extended, then answer should be continue to move to the left. Then third, rapid sweep with right hand. For rapid sweep with right hand, first is move considerably to the right. And if they ask for a left hand, then the answer should be move considerably to left. Okay, so this is the answer for signal and actions. Then these are the some hand signals with the message. So you can go through this. Most of the questions in most of the exam, the questions are asked from this data. Question number 18. Which of the following beam is supported on more than two support? Okay, so here they ask which beam is supported on more than two support. First is cantilever beam. So cantilever beam is supported by one support or is supported singly. So that support is fixed support. Then second, simply supported beam supported by two supports. In that one is hinge and another one is roller. Okay, then third, continuous beam is supported with more than two support. So answer should be option number third, means from the below only third means option number 2 is correct. Then question number 19. As per National Building Code of India 1970, which of the following is a Group C building? So options are educational building, assembly building, institutional building, residential building. Okay, so from this, the Group C building is institutional building. Okay, so this is the chart for building or National Building Codes of India. So here Group A is a residential, Group B is a educational, Group C is institutional, Group D is assembly, Group E is a business, Group F is a mercantile, Group G is a industrial, Group H is a storage, and Group J is for the hazardous buildings. Okay, so how to remember this series or how to remember it linearly? So for that there is one trick. So here in the residential, 1 minute. So here in the residential word, first alphabet is R. Okay. In educational, E. In institutional, I. Then for assembly, A. Then for business, B. Then for mercantile, M. Then for industrial, I. Then for storage, S. And then for hazardous, there is H. Okay. So remember the first alphabet of each word, that R E I A B M I S H. So Riya Abmish is the alphabetical series for this. Okay, this is just a trick. If you remember like this only, so you can remember it. But if you have some difficulty to remember the all the order in a series, so you can remember it like this. Riya Abmish. Okay, so one confusion is here that institutional is I and for industrial also I. So remember that the institutional is C and industrial is G. Okay, so in the group A, B, C, D, E, F, G, H. Okay, up to H. This is in alphabetical series, but here they replace I with J. So remember this group J as a hazardous. So option number third is correct here. Group C building is institutional building. Then question number 20. In the context of oil paint, which of the following is used to hide the surface imperfections and to impart the desired color? Okay, so here they ask, in the context of oil paint, which of the following is used to hide the imperfections? Okay, wall imperfection. To hide the wall imperfections, which thing is used with the desired color? So that is pigments. So the answer of this question is pigments. Here, the vehicle. Okay, so option pigment is correct, but the remaining things need to be discussed here. So first is vehicle. So vehicle is an liquid substance which hold the ingredients of paint and adjust the viscosity of paint to spread it evenly. Then next is dryer, which is used as a catalyst for oxidation, polymerization and condensation. Then question number 21. Which of the following statement is correct assumption regarding the Euler's column theory? So there are many assumptions related to Euler's column theory. So in these options, first is the self weight of column is taken into account. So first is not correct. So because the self weight of the column is not taken or not considered in the Euler's column theory. Then second, the column will fail by buckling alone. So second is correct. Column is failed due to buckling. And then third, the length of column is very large as compared to lateral dimension. This is also correct. Then here the option number second and third is correct. So option number 4 is correct here. Only second and third. So here some extra assumptions related to Euler's theory. So first is column is initially straight and load is applied tangentially. Second, cross section is uniform throughout the length. Then column is homogeneous, isotropic, perfectly elastic and obeys Hooke's law. Obeys Hooke's law means stress is directly proportional to strain. Okay. Then length dimensional is large than other dimension. So here in the option number 3, the same point is given. The length of column is very large as compared to lateral dimension. So here the length of dimensional is very large than other dimensions. Then self weight of column is negligible. So here they in the first they said self weight of column is taken into consider, but the self weight of column is negligible here, and this is the assumption. Then column fail due to buckling alone. So here second is correct. Column fail is due to buckling alone, and direct stress is very small as compared to bending stress. So these are the assumptions related to Euler's column theory. Option number 4 is correct. Then question number 22. Which of the following is a method of valuation? So rental method of valuation, correct. Then second, development method of valuation, also correct. And then third is depreciation method of valuation. This is also correct. So all the three are the methods of valuations. So option number second is correct. And these are the some extra methods related to valuation, which are residual method, investment method, comparative method, profit method and contractor method. Then question number 23. Which of the following is a part of reciprocating pump? First is piston, second cylinder, third is impeller. First, piston and cylinder both are the parts of reciprocating pump, but the impeller is not the part of reciprocating pump, which is the part of centrifugal pump. So impeller is the part of centrifugal pump. So answer is option number first and second, means piston and cylinder is correct. So option number 2, only first and second is correct here. Then question number 24. Which of the following statement is correct regarding the compression member? So first is a compression member is a structural member. Yes. Which is straight and subjected to two equal and opposite compressive forces applied at its end. Correct. Then second, strut is a compression member used in the roof truss and bracing. And second is also correct. Here the answer is first and second both are correct. So option number 2 is correct. So in this figure, these are the struts and these are the compression members in the roof truss and bracings. Okay. Then struts are the web member which are subjected to light axial compressive loads. Then last question of this session. In the context of tension member, the permissible stress in axial tension on the net effective area of the section should not exceed dash, where Fy is the yield stress of steel in megapascal. Okay, so here they ask for a axial tension. Okay, for the axial tension, so the answer is 0.6 Fy, 0.6 into yield stress of steel in megapascal. Okay, so here are some type of forces with their permissible stresses. First is axial tension in compression. For that 0.6 Fy is correct. Then for bending 0.66 Fy. Then for bearing 0.75 Fy. And then for average shear 0.4 Fy is the permissible stress. Option number 3 is correct here. Okay, first MCQ. So first MCQ is identify the correct expression among the following. Okay, so what is the correct equation? Here by observing the options, here Young's modulus is given, here Poisson's ratio given, Young's modulus and Poisson's ratio. Okay, here we write first the formulas of Young's modulus and Poisson's ratio. So Young's modulus is also known as modulus of elasticity. Okay, Young's modulus is also known as modulus of elasticity. There are three types of modulus of or elastic constant. In that, first is the Young's modulus, which is known as modulus of elasticity. Young's modulus represented by E. Second one is bulk modulus. Bulk modulus is represented by K. And third one is modulus of rigidity or shear modulus. Okay, these are the three elastic constant. And here the shear modulus is represented by E, also known as modulus of elasticity, and formula is stress by strain. Formula is stress by strain and unit is Newton per mm square. Okay, this is the unit for Young's modulus. Then next formula is about the Poisson's ratio. So Poisson's ratio is nothing but ratio of lateral strain to longitudinal strain. Lateral strain to longitudinal strain. Okay, by observing both of the formulas here, we will decide which option is correct here. Okay, here they ask a correct option. So first is Young's modulus is equal to strain by stress. So here stress by strain is correct. So first option is not correct. Then second, lateral strain is equal to Poisson's ratio into longitudinal strain. Okay, here we take this denominator term into this side, and if we multiply this longitudinal strain with Poisson's ratio, then that answer is equals to lateral strain. So option number second is correct here. Okay, but we'll see the next options C and D. So C is Young's modulus is equals to strain into stress. So here multiplication is incorrect. So option C is wrong. Then next is lateral strain is equal to Poisson's ratio divided by longitudinal strain. So here divided is also wrong. Here if here they give a multiply sign, then it's correct. So option D is also incorrect. So option B is the correct answer. The next question. Then question number second. A steel bar of 8 mm is heated from 10 degrees Celsius to 25 degrees Celsius and the bar is free to expand. The bar will induce. Bar is free to expand, then it will induce. What it will induce? So first, if a temperature increase on any material, it increases its size or length. Here we take a length. If temperature decreases, it decreases its length. Okay. And if the expansion and contraction is prevented, or restricted, okay, then internal resisting force is generated. If expansion and contraction is prevented, then internal resisting force is generated, and that is known as a temperature stresses or thermal stresses. Okay, thermal stresses and temperature stresses. Okay, so what is the change in length? So change in length here we represent with the help of dl, which is delta into L into alpha. Okay, so and if the thermal strain is nothing but a change in length to original length. So here delta into L into alpha is equals to L divided by L. L cancel here. So delta into alpha is nothing but a epsilon t. Okay, but in this question they mention free to expand. Free to expand means here no restriction or no prevention is there. No restriction means no stress. So answer is B. If they here mention they prevent to expand or they stop to expand, then tensile stresses or thermal stresses induced, then temperature stresses and thermal stresses induced, not a tensile stresses. Okay, prevented, then thermal stresses. If free, then no stresses. So option B is correct. Then question number third. So third question is, when a round bar material with diameter of 37.5 mm. So here we write given diameter is 37.5 mm. Then next length is 2.4 meter. Then Young's modulus is 110 giga Newton per meter square. Then shear modulus represented by G 42 giga Newton per meter square. Then stretched for 2.5 mm means delta L, change in length. Okay, which is 2.5 mm. Then they here mention bulk modulus will be. So bulk modulus means K. We need to find out a K here. Okay, first we convert the meter into mm for easy calculation. So 2.4 mm, if we convert meter into mm, then this is the conversion. 1 meter is equals to 1000 mm. So here 2400 mm. Okay, then 110 giga. So 110 giga means 10 raised to 9. And for converting this meter into mm, here we take 10 raised to 3 for 1 mm, but here they give a square. So here we take 6. Okay, so after cutting the values, here we get 10 raised to 6 and 10 raised to 9 cut. Then here 10 raised to 3 is remaining. Okay, so we'll write here 110 into 10 raised to 3 Newton per mm square. Okay, so here similarly the same procedure, 42 into 10 raised to 3 Newton per mm square. Okay, remaining is an mm square. Then for bulk modulus there is one formula which is E equals to 3K in bracket 1 minus 2 mu. But E is known, K is unknown, and we'll need to find out the K here. Mu is also unknown. Okay, so for mu means Poisson's ratio, first we find out this mu. So E has another formula, E is equals to 2G 1 plus mu. Here G is known, mu is unknown, and E is known. Okay, E is 110 into 10 raised to 3 equals to 2 into 42 into 10 raised to 3 in bracket 1 plus mu is here. So mu value is 0.31. 0.31 is nothing but a mu here. Okay, so we'll put that mu into this formula. So E is 110 into 10 raised to 3 equals to 3 into K is unknown in bracket 1 minus 0.31. Okay, so by calculating this we get K as 96 giga Newton per meter square. Okay, you can calculate these answers. So here we get the bulk modulus as 96 giga Newton per meter square. So option B is correct. Formulas are E is equals to 3K in bracket 1 minus 2 mu and E is equals to 2G 1 plus mu. These are the two formulas. Trick is here converting the meter into mm and converting the giga, 1 giga is equals to, or you can take for giga is 10 raised to 9. Okay, so by using this we convert this E and G into Newton per mm square. So this is how the question and answer is 96 giga Newton per mm square. Option number second is correct. Then fourth question is, how much in percentage, how much fracture strain is commonly adopted as a border between brittle and ductile material? So border between brittle and ductile material. So if the material is said to be ductile, then the percentage of elongation is more than 5%. Percentage of elongation here is more than 5%. More than 5%. And then in case of brittle, percentage of elongation is less than 5%. Okay, so it is in between 5. Okay, so here the how much percentage of fracture strain is commonly adopted in border. Okay, so here for border the percentage is 5. So option number first is correct. 5% of fracture strain is commonly adopted as border between brittle and ductile. So basic terms, ductile is nothing but if we convert the steel material into wires, okay, into wires, then it has a ductile property, and brittleness is a lack of ductility. Lack of ductility is nothing but a brittleness or a brittle material like glass, and ductile materials are mild steel, aluminium, then copper and lead. These are the ductile materials. Ductile, DW, you can remember like that, DW, ductile wires. Okay, if we need to convert the material into wires, then tensile force is required. Tensile force is required. So in case of ductile material, they bear a tensile nature of force. Okay, and in case of malleability, okay, so you can remember this malleability as MS, malleability into sheet, and ductile as wire. Okay, sheet means malleability as a property which can resist a compressive force. Okay, if you apply any kind of compressive force on a malleable materials, then it convert into sheet. Okay, and if you apply a tensile force on a ductile material, it will convert into wires. Okay, so option number first is correct for this question. Then next question, fifth question is, total number of elastic constant and independent elastic constant for material are. So elastic constant and independent elastic constant, for that there are 3 categories. So here we make a column for that. So in that first we take elastic constant, and in the second we take a independent elastic constant. Okay, so first for isotropic, then second for orthotropic, then next for anisotropic. So isotropic, inelastic or independent elastic constants are 2, 9 and 21. 2, 9 and 21. In case of elastic constants, dependent elastic constants are 4, 12 and infinite. Okay, this is the important table. Okay, here they ask total number of elastic constant and independent elastic constant for material. 5, 3, 4, 3, 4, 4 and 4, 2. Here this 4, 2 is matching here. So for the elastic constant for dependent and independent materials are 4 and 2. So here option number D is correct. So option number D is correct here. And if here they give an option like 12 and 9, infinite and 21. So you can choose as first, second and third. Each and every option has the answer in this three. But here they only mention a 4 and 2. So for the fifth question, option number D is correct. But this table is very important. So remember this. They ask this question in any exam. So mark it as an important question. Then we move to next question, question number 6. Then question number 6. A fixed beam is loaded as in figure. The fixed end moment at support A is. Okay, so here they ask a fixed end moment. Okay, so in the previous video, I'll given that chart which is related to fixed end moment for fixed beams, and from that fixed end moments, most of the questions are asked because these values are constant values, and they directly ask what is the value for this kind of a beam, if it is related to or if it is subjected to point load, subjected to UDL, subjected to UVL, subjected to eccentric point loading, subjected to half span of UDL or half span of UVL. So these kind of fixed end moment questions they ask, and this is the important question. In the previous exam within 1 year, they ask minimum two questions from the fixed end moment. So that's why this is the important chart. It has only 8 to 9 formulas, and all the formulas are important. So here this formula for the UVL, so UL formula they ask for support E. Okay, but we'll see for support A and support B. For support B, the formula for fixed end moment is WL square by 30. Okay, but minus is here. Minus is here. In case of support A, WL square by 20. Okay, so option B is correct. WL square by 20. Then next question, question number 7. Then question number 7. In the continuous beam shown in the following figure, support moment M at 3 in kilonewton meter is. In kilonewton meter is. Okay, support third. Here they want to calculate, or they ask to calculate the support moment at this third point. So third point here roller support is there. For second also roller support. For first fixed support. Before solving any kind of a beam numerical, first we know about the support and what kind of reaction and movements are acted on that kind of support. So in case of fixed support is prevented or restricted in a horizontal movement, horizontal direction movement, also prevented in vertical direction movement. Okay, restricted in this movement, and it also restricted in case of a movement due to the rotational force acted on the any kind of a beam on the fixed support. Okay, so it is restricted in these three. So this fixed force or fixed beam support is with the three reactions, and in case of a hinge support is restricted and prevented in a vertical direction movement, in a horizontal direction movement. So here two reactions are there, and it does not restricted in a movement, so it does not get restricted here. So movement value is here we need to calculate the movement acted on this hinge support, and in case of here movement is 0. Okay, movement on hinge support is 0. In case of roller, we represent a roller support like this. So in case of a roller, the only vertical direction movement is restricted or prevented. Here horizontal and movement both are not present, and movement for roller support also equal to 0. So option number last, option E is correct here. For the support third, the support movement is 0 because roller support is given here. So the movement is 0. But if they ask for a fixed support, there is a one value which restrict the movement. Okay, here one value which restrict the movement, and that movement value we need to calculate here. But in case of a roller and hinge support, there is a no value of a movement, because here in case of a roller and hinge support, movement happens. Okay, movement happens. That's why no restriction movement value, no restriction movement value in case of hinge and roller support. That's why the movement value is 0 in case of roller and hinge. But in case of fixed support, for any kind of a movement, there is a restriction movement present in a fixed support. So that's why there is one value of movement in the fixed support. Okay, so option A is correct here. Then we'll see the next question, question number 8. Then question number 8, the elastic curve of a beam means. Okay, in case of a beam, bending moment term is there, shear force diagram term is there, and stress strain curve is there. Stress strain curve is a term which is related to tensile test. Tensile test on any kind of a steel or any kind of a RCC beam. Okay, so that's why we calculate the tensile test on steel, and we'll get the stress and strain curve. Shear force diagram is obtained by calculating the shear force on each point and joining that point on a beam. Same bending moment is obtained like that, calculating the bending moment on each and every point and joining that bending moment point on the beam. But in case of elastic curve of a beam, that elastic curve of a beam means deflection curve. So option C is correct here. Question number 9. A prismatic beam is shown in the figure given below. So this is the beam with internal hinge. With internal hinge. This is roller support. And this one is hinge support. Okay, here they ask that consider the following statements. Which of these statements are correct statements? Okay, so we'll see the each statement one by one, and then we'll decide which statement is correct and which is incorrect. First one is structure is unstable. Structure is unstable. Okay, first let's discuss which is correct or not. First statement is the structure is unstable. So unstable, there are two rules for deciding the stable. There are two rules for deciding whether the structure is stable or unstable. So first rule is that this is the simply supported beam. We'll take it as a simply supported beam. Okay, horizontal force here 0 because there is a no horizontal force acting on this beam, and these are the two vertical forces acted on this beam. Okay, so if all the forces on the beam are parallel to each other, all the forces on the beam are parallel to each other, then that structure is externally unstable. Then that structure is externally unstable. Then second is, consider this as a simply supported beam with a roller support, but that roller support is in an inclined condition. Okay, here in this condition, both the vertical forces are concurrent to each other, means the forces are meet to each other at some point. Okay, at some point they meet to each other. If all the forces on beam are concurrent to each other, then that structure is externally unstable. Okay, so here in this case, this beam, both the forces are vertically upward and parallel to each other. So that's why this is externally unstable. So first statement is correct. Then second, the bending moment is 0 at support and internal hinge. Here in case of bending moment for hinge and for roller are 0, and at the support and at the internal hinge both the bending moment are 0 for the support, which is hinge and roller, and for internal hinge bending moment value is 0. Then next it is a mechanism. This is also correct. Then it is a structurally or statically indeterminate structure. Statically indeterminate structure means that kind of structures which are not solved by equilibrium equation. Which are not solved by equilibrium equation. Equilibrium equations are three, that is summation of f of x is equals to 0, summation of f of y equal to 0, and summation of moment equal to 0. If by using these three conditions any kind of a beam are not solved, then that structure is known as statically indeterminate structure. But in this given beam, here horizontal force is 0, only two vertical forces are remaining, so that's why that two vertical forces values are calculated by this equilibrium equation. So that's why this structure is statically determinate structure. So this fourth statement is incorrect and option number first is correct, and that first, second and third statements are correct. So option number A is correct for question number 9. Then question number 10. So question is the maximum magnitude of shear stress due to shear force F on a rectangular section of area A at the neutral axis is. So maximum of magnitude of shear stress. So shear stress formula is tau is equals to say by. I mentioned this trick in a short notes video. So say by is a trick for the shear stress formula, and for maximum shear stress the formula is here one constant is there and then tau average. Okay, so this kind of formula are used for different kind of sections. Here they ask for a rectangular section. So for rectangular section, tau max formula is tau max is equals to 3 by 2 tau average about its neutral axis. Okay, so here tau average is nothing but, so tau average is nothing but S by BD. S is nothing but a shear force. Here shear force is represented by F. So take S as F, and BD is nothing but area of rectangular section. So take that area as capital A. So 3 by 2 into F by A is the shear force or maximum magnitude of shear force acted upon this rectangular section about its neutral axis. So option C is correct, 3 by 2 into F by A. Question 11. Consider the following statements. The theory of simple bending assumes that, so these are the four assumptions of the above statements which are correct. So first assumption is the material of the beam is homogeneous, isotropic and obeys Hooke's law. So first statement is correct. Material is homogeneous, isotropic and that obeys Hooke's law. Hooke's law is nothing but stress directly proportional to strain. This is the Hooke's law. Okay. Then next, the plane section remains plane after bending. This is also correct. Plane section remains plane after bending. Then third is each cross section of the beam is symmetric about the loading plane. This assumption is also correct. Then Young's modulus or Young's moduli are the same in tension and compression. Young's modulus is same for a steel. Young's modulus is same for a concrete. Means in case of each and every concrete, Young's modulus is same. In case of steel, Young's modulus is same. So in case of tension and compression, the value is also same. So this is the correct assumption. So option number 4 is correct. First, second, third, fourth, all the statements are correct for this question. Question number 12. A steel plate 50 mm wide and 100 mm thick. 50 mm wide and 100 mm thick. This is a steel plate. Means B is 50 mm and D is 100 mm. Is to bend into circular arc of radius 10 meter. R is equals to 10 meter. And Young's modulus is 2 into 10 raised to 5 Newton per mm square. And then maximum bending stress induced will be, maximum bending stress is sigma. Okay, to calculate sigma there is one formula which is m by I equal to sigma by y equal to E by R. Here sigma need to calculate which is maximum bending stress, then y is also given, E given, R given. So take this formula, sigma equals to E divided by R into Y. E is 2 into 10 raised to 5 into Y. Y is the distance between neutral axis and the point where we need to calculate the maximum bending stress. This is Y. So Y is 100 by 2, which is half, divided by 10. 10 is in meter, so convert it into mm. So after calculating this, we get the value of maximum bending stress as 1000 Newton per mm square. So option D is correct for question number 12. Then question number 13. Match the list 1 and 2nd and select the correct answer using the code given below the list. First column is for real beam support condition and second corresponding conjugate beams support conditions. So first, for fixed beam, in case of real beam, there is a fixed support, but in case of conjugate beam, we take as a free end or a free support. Okay, so for option A, fourth is correct. Then for free end, fixed end or fixed support we take. Then for internal or interior support we take a hinge, and for hinge we take a interior support. Okay, alternate options are there for real and conjugate beam. So the option number for fixed support free end means 4 here. For free end fixed support 3 here. Okay, so option D is correct for question number 13. Question number 15. In the procedure of Macauley's method for getting the deflection equation, in Macauley's method, there are twice the integration happens. Okay, so here in the first option once, here twice, so option B is correct. Thrice, option C is incorrect, this is incorrect, and this is incorrect. Okay, twice means first the integration of equation of flexure. Okay, integration of equation of flexure, first integration. Okay, first time, that convert into a slope, and second integration of equation of flexure converts to deflection. Okay, so this is how the Macauley's method, in that the differential equation of a flexure is integrated for twice. Option B is correct. Then next question number 15. In that first, match list 1 and list 2nd and select the correct answer using the codes given in the list. First list is with a beam and loading, and second is with a maximum deflection. Okay, the total chart of this deflection and slope I mentioned in a short notes, and in this video we'll see the deflection, how to calculate the deflection from movement, then slope, and then deflection we'll see for the first beam. So first beam is cantilever beam with a point load at its end. So movement for that beam is, bending moment for that beam is W into L. Then slope. There are some constant to find out the slope and deflection. So for slope, ML by EI. Here just replace this M, means movement, with WL. So WL square divided by EI. Then deflection. Deflection is equal to slope into L by 3. So here slope is WL square divided by EI into L by 3. So total deflection is WL cube divided by 3 EI. So for first, WL cube divided by 3 EI, option number 3rd is correct. Then we'll see the codes here. So for first option, for A, 3 is there. So option number 1st is correct. But we'll see what are the values of deflection. So for B, this is cantilever beam with UDL. With UDL, first option is correct, which is WL cube divided by 8 EI. Then third, C, simply supported beam with point load acted centrally. and the deflection is WL cube divided by 48 EI. Then last, simply supported beam with UDL, option number 4 is correct, which is 5WL cube divided by 384 EI. So option first is correct here. Then next question number 16. 16 is the extremities of any diameter on Mohr's circle represent. Okay, here Mohr's circle we use to find out the principal stresses. To find out the principal stresses, there are two methods. In that, first is analytical method and second one is Mohr's circle method. Okay, these are the two methods to find out the principal stresses, and this analytical method and Mohr's circle method are used to find out the principal stresses, and in the principal stresses they are found the normal and shear stresses on the plane. So here the extremities on the diameter of a Mohr's circle is normal and shear stresses. So option D is correct for question number 16. Next question. Then question number 17. The state of plane stress at a point is represented by the stress element below, assuming a tensile force positive and compressive force negative. Tensile force positive, compressive force negative. The principal stresses are, first of all, the formula for principal stresses is sigma max or minimum equal to sigma x plus sigma y divided by 2 plus minus square root of sigma x minus sigma y divided by 2 whole bracket square plus tau xy whole bracket square. Okay, so here sigma x is equals to 50, which is tensile, so plus 50. Then sigma y compression, so take it as negative, minus 10. Then tau xy is 40, so here 40. Then put that value into the formulas. 50 plus minus of 10 divided by 2 plus minus square root of 50 minus of minus 10 divided by 2 whole bracket square plus 40 bracket square equal to, after calculating we get 20 plus minus 50, sigma max or minimum. So in this formula, if we take a plus sign during calculation, we get sigma max, which is 70. If we take a minus sign, then we get sigma minimum, which is minus 30. So here option B is correct, 70 and minus 30. Option B is correct for question number 17. This is maximum principal stress. This is maximum principal stress, and this is minimum principal stress. Next question. A solid circular shaft of diameter 8 mm is exposed to a maximum torque of 64 Newton meter. What is the shear stress in the shaft? So to find out the shear stress, this is the formula. Tau is equals to T into R divided by J. And here for circular section, the value of J means polar moment of inertia is pi T raised to 4 divided by 32. T value is given, which is 64 into 10 raised to 3. Convert it into a mm, Newton mm, and R is the D by 2, 8 by 2. So after solving this equation, we get the answer as 2000 divided by pi. So option B is correct for question number 18. The next question, Euler's buckling load for a column whose both ends are fixed, having a length of L and modulus of elasticity is E, the moment of inertia I is. Okay, to find out the Euler's buckling load, formula is PE is equals to pi square EI divided by LE square. Okay, LE is the effective length, and to find out the effective length, here one condition is there, both ends are fixed. If both end of the beam are fixed, then deflection is like this for this kind of a beam, and the L effective is, or effective length is L by 2. So put this LE into this formula. P is equals to pi square EI divided by L by 2 whole square. By solving this, we get 4 pi square EI divided by L square. So this is the value for the Euler's buckling load, and here the answer matches with option B. So option B is correct. 4 pi square EI divided by LE square. Then last question from my list of MCQs. In a beam, the bending moment is maximum at the point where shear force is. Okay, for that here I consider one example. This is a simply supported beam, and this simply supported beam is subjected to point load with 2 point loads, and that point loads are equally distanced from its support. So this is the shear force diagram for this particular beam and shear force diagram, and this is the bending moment diagram for the particular beam. So here, when the this shear force change its sign from positive to 0 and here from 0 to negative, okay, at that point the bending moment is maximum. Okay, so here in the question, in the beam the bending moment is maximum at the point where shear force changes its sign. So first option is correct. Then next question. Then this question is from the comment section, and the question is, a composite bar shown below is made of steel and copper. The coefficient of expansion of steel and copper are alpha and 1.25 alpha respectively, while the elastic moduli are E and 0.5 E respectively. Estimate the stresses induced in the member due to a temperature rise by T degree Celsius. Here temperature rise they mention. Okay, so this is the steel beam and this is copper. Okay, this is the composite bar of steel and copper. Okay, in this case they mention here the alpha means coefficient of thermal expansion for copper is more than the coefficient of thermal expansion of steel. Okay, so to calculate the temperature or thermal stresses, the formula is sigma is equals to E into alpha into delta T. Means this thermal stress is depend upon the elastic moduli, then coefficient of thermal expansion and temperature. Okay, there are two conditions, that if temperature is rise by T degree Celsius and if temperature lowers by T degree Celsius. So first we see the temperature lowers by T degree Celsius. So this is the copper, and here in case of copper the coefficient of thermal expansion of copper is more than the steel. Okay, and temperature here we decrease the temperature or we lower the temperature. Okay, so this is condition about lowering the temperature. If the temperature lowers, then the alpha value, okay, here alpha value of Cu is larger, so in that case the copper is goes under the tension, okay, tensile nature, and steel undergoes compression nature. Okay, this is how the compression goes to copper, goes to steel, and tension is goes to copper. Okay, then next condition is when the temperature is rise by T degree Celsius. Here temperature rises. If temperature rises, then the coefficient of copper is larger and coefficient of steel is smaller. If the coefficient of copper is larger, then copper is subjected to compression here and steel is subjected to tension or tensile stress. This is how. Steel subjected to tension and copper subjected to compression. And for this particular example, here they mention temperature rise by T degrees Celsius. So the estimate the stresses induced in the member. So these are the stresses induced in the member. For copper, compression stress is generated, and for steel, tensile stress is generated. The second condition is for this particular example. If this same numerical is with the lower temperature or temperature lowers by D degrees Celsius, then this will be your answer. The next question. Then next, this is the second question, and the second question is similar to the question asked in a comment section. Here I take a different value or different MCQ, but the steps to find out the answer is similar in this question too, but in this question some more points are to be covered, so that's why I take this question, and which is similar to the comment section question. So question is, a compound bar is constructed from 3 bars 50 mm wide and 12 mm thick, fastened together to form a bar of 50 mm wide and 36 mm thick. The aluminium alloy bar in the middle has Young's modulus is 70 for aluminium and 100 for brass. Then brass and aluminium, if the brass is originally fastened at 18 degrees Celsius and temperature of entire assembly is subsequently raised to 50 degrees Celsius, and here alpha value and 18 per degree Celsius, and second alpha value is 22 per degree Celsius. This is for the aluminium and this is for the brass. Okay, so here the steps are, first the force in a aluminium and brass, force in a brass and aluminium are same. Okay, force formula is stress into area, stress into area. So here we equate the values of forces of brass and aluminium. So for forces, first we take the stress value as x for brass, then for area 50 into 12, but here the brass is 2 in numbers, so take as a 2 here, and then sigma A for the stress of aluminium into area is 50 into 12. Aluminium member is single, so that's why I take it as 1. Then after calculating we get sigma A as 2x. Okay. Then next formula here to use is equate the values of change in a length to the values of stresses. So that change in a length is PL by AE plus PL by AE. This is for brass and this is for aluminium, is equal to alpha A minus alpha B into T2 minus T1 into L. So this is how the formula. Then here P by A is nothing but a stress. Okay, so here stress is X for brass, then L, take it as a L, then E is as 100 for the brass, so take 100, and for giga take 10 raised to 9 plus 2x as a sigma A into L divided by 70 into 10 raised to 9 equal to alpha A means the coefficient of thermal expansion for the aluminium is 22 minus 18 for brass, then into temperature is 50 minus 18 into that length. After calculating these value, you get the X as 3.32 megapascal, and that sigma A means twice of X get as 6.64 megapascal, and this stress for the brass gives you a tensile stress, and for the aluminium gives you the compressive stress. Okay, so this is how the example, and this example is similar to the example asked in a comment section, and I hope you get to solve your doubts, and Thank you for watching the video.